So in the last class, we have just seen introduction part, like a theoretical part of like how many data structures are there, what type of data structures we are going to implement and all. But see, so once again, whenever we are going to implement data structures, Python is always providing predefined functionality. But here we implement with a manual implementation. We never use predefined functions. Because if we use a predefined functions directly, which already contains the logic, means what? We can say that existing things we are using simply. How? I'll explain. So one by one. First thing, how to create that stack and what is that stack? First one, that stack data structure we are going to implement. Just like array representation only, but instead of representing the values side by side, we are representing the values top down approach. In this format, we will represent the data. Let us take this is the stack. Let us take this is the stack is a 1. Suppose I'm just giving that initial size of the stack is a 0, 1, 2, 3, 4. Just consider all operations we are performing. If you want to insert the element from the top only, or if you want to delete the element is from the top only, everything. So that's why we are representing one variable top, which is representing the index. But initially I'm taking top equals to -1. Top equals to -1. And this is important. Size of the stack is 5. Size of the stack is 5. Sir, how can we create everything? You will understand. So initially top is not pointing to any index because no elements in the stack. No elements. So that is only the condition we will use always if the top of the stack equals to -1, simply we can say that stack is empty. This is stack is empty condition. If they ask, tell me the condition to specify stack is empty. Whenever the top equals to -1, we can say that stack is empty. Okay, next. Now I want to insert the data. Here it is. Insertions we are writing. Look at this. Insertions. Suppose if you call function is a push function, push. What is the element you want to push? That is you are passing. Let us take a 10. 10 you are passing. First step is, see, you have to push the first element from the top only. But see, it will go down, go down, go down, go down. It will stay here. It will stay here. Nothing but in the 0th location, the first element will be. So simply we can say that top plus plus. In Python directly you can't use plus plus. Top value increase by 1. Then you can say that into that stack of top location, you are storing that element. Element is a 10. The 10 will go and store into top location, top value 0. So into that 0th location, the value 10 will store. Like this, we keep on doing insertion operations. Push 20, the top will increase. Same operation only, every time same operation. Like a push 30, push 40 is a push 50, suppose. So here top value, top plus means what? Value becomes 0, into that 0th location it is moved. Every time the top value increase, top value 1 into that first location 20, top value 2 into that second location 30, top value is a 3 into that location 40. Next, top value 4 into that location value is a 50. Now is the top is full. Top is full. Here you need to specify top is a full because size is a 5. We have already stored 5 elements is a 1. So when size and top plus 1 equal, because top value starts with a 0. So when it reaches 4, if size value equal to top plus 1 or top value equals to 4 na, size minus 1, then simply we can say that stack is full. Simply we can say that stack is full. Whenever we are inserting, we need to check first. Directly we should not insert. First we have to check is the stack is full or not, because if stack is full, you cannot perform insertion operation. That is right. Now if you want to delete from the stack, now it is useful. First you have to check stack has elements or not. Reason, if stack has no elements, you cannot delete elements from the stack. So if you want to perform deletions, first we have to check stack is empty or not. If it is not empty, then do. I want to delete this top, which is already pointing by this top is a 1. So here simply we are writing, first we are printing that item we are going to delete. Delete means pop stack of top value, because always you are deleting the top element only. After that, top value we should decrease. Top equal to top minus 1. Nothing but here that 4 will become 3. Then now top is pointing to this one is nothing but this element deleted. Sir, you are not deleting the element anywhere. This is a very, very important note. It's very, very important note. It is impossible. It is impossible to delete the data in location. Only thing is what? We make the pointer, here it is a top, not pointing to that location. We just remove the reference of that location. So no one can access the data. Next one, suppose if you insert, that the data will be replaced when we insert the data. Suppose sir, again I want to insert. Look at this. I'm just pushing the element 60. I'm push. Then what will happen? Again is a top plus one. And then is a stack of top. Stack of top value is the element now. So again that value become 4. Then that 60 will store in place of this 50. Only one point you need to remember. We just make the pointer not pointing to that location. Only that much we can do. Only that much we can do. Instead of that, we cannot take the, means what? We cannot delete the data manually. This is only called a deletion. And next one is a printing. Printing is a top to 0. We are printing. Top to 0. Just repeat the loop. Each element you can display. Each element you can display. So by taking that range in the for loop, suppose here it is for taking one variable I in the range of sir, I need a 0 to top, means in range function we need to take one extra variable, extra value now. Taking that print stack of I. Listen, top value is what? 3. This is not there element. Listen, deleted. Top element is a 3. So if you want to print up to 3, you have to give 4. That is the range function that you know already in a Python how range works. But it is printing from 0th location. Sir, 10, 20, 30, 40 will display. No, sir. I want to print 40, 30, 20, 10. In reverse order, we need to print. In a reverse order, we need to print. For I in the range of starting from the top, you should end with a 0 means what? 0 minus 1. Minus 1 we have to give in decreasing order. In a decreasing order. I'll show you practically. See, starting from the top location value 30. That is what? 3. Next 3 minus 1, 2, second location. 2 minus 1, 1, first location. 1 minus 1, 0, 0th location. 0 minus 1 is a minus 1. It will reach na? Whenever it will reach this bound, it will stop. Whenever it reaches the bound, it will stop. That is the way. This is the way we are creating. This is the way we are creating. Now, I'm implementing the stack. I'm implementing the stack. For that, so whatever the knowledge is required, first I'll explain that knowledge. Then I'm using. Simply I'm using online compiler. Simply I'm using online compiler. This is the one. First general example I'll explain. The same thing we implement in the stack. Class name I am taking is anything. Let us take a test. Okay. 2 types of methods are there normally. One is a suppose ABC. We are just printing that ABC. Next one is a XYZ. But this is actually called self. Is a self XYZ. So normally in Python, this method without self is called static method or class level method. static or class level method. How can we access these type of methods? Directly by using the class name test dot abc. Test dot abc. It will execute static abc. But this xyz, if you want to call with a self word, there is a rule that you have to create object. You have to create object for this test class. This is object creation. This is what? Object creation. Using that object only, we have to call that method xyz. xyz. This method is actually called dynamic or instance or object level. Different names are there. Now, in all the implementations, we follow this approach. Everybody, you have to understand. This is the one. Got it? Now, one more point I'm going to explain because one more thing I will use. See, you are creating object now. You are creating object now. I'm just removing this one and this one. Just creating object. In the process of object creation, there is a method called constructor. Define double underscore init double underscore self. You must write like this only, without spaces, double underscore. And this is called constructor. It's called what? Constructor. That we are going to execute. Constructor is going to execute. Constructor is going to execute. That we are writing is a one. See, whenever you create object, automatically this constructor executes. Sir, what is the use? What is the use? Let me explain first. I'm taking one employee class. Okay. Inside I'm taking double underscore init self. I'm giving like this: employee number, employee name, employee salary. That you are assigning like this: self dot number, self dot name, self dot salary, self dot salary. And one method also we are writing. Look at this: details. Details. Inside, I'm just printing is a self dot number, self dot name. Only just two I'm printing. I'll explain. Wait. E1 is equals to, I'm creating object. I'm passing the details 101, employee name and employee salary. Creating object is 102 is employee name and employee salary. And simply we call E1 dot details and E2 dot details. First, let me explain this, why I have written this code. First one is this line execute. This line execute. What is this meaning? Object creation of employee class. Object means the memory will be allocated like this. At some location, we can say that address. Then constructor will call. This self holds that address 5164, pointing to that one. Pointing to that one. And this 101 will go and store into this number. Amar will go and store into this name. 35,000 will go and store into this salary. Got it? Now, that value will assign to this self.number, self.name, self.salary. Nothing but into that number. So 101 will store. Into that name will store. Into that salary that will store. Sorry. Into that salary that will store. Self is pointing to this object. Then that address will store into this E1. E1 means this 5164 will store. First object is ready. Now, one more object we are creating. Nothing but, so this is the object, second object. Again, different location, we collect into E2. Again, same story. Now, self is pointing to new object. Self is always pointing to the current object. Pointing to what? Current object. Now the values will store into this new object. Is a 102 name and is a salary like this. As the same address will assign to this E2. So whenever you call E1 details means what? That E1 address will store into self. So self.number, self.name, self.salary. These things will print. E2 dot details means what? E2 address will store into self. So that second object details will print. Second object details will print. This is the one. So whenever we run this application, that output will be like this. Output will be like this. Because whatever the code we have discussed, stack implementation, now we are implementing that stack in the same process only. In the same process only. That is. Hope you got it. Now, what I am doing? I am writing the code. It's very, very important. See, here we are writing that stack code first time. The same code we are implementing for multiple things. Queue, circular queue, double-ended queue. So once you implement with everything, that writing, the way you are writing the code will be easy. So now we are writing that, taking that our own class is a stack. And for creating that stack, we are using double underscore init double underscore self. It's compulsory. And I'm collecting that size. First, we have to create that stack. Sir, how to create that stack? Self dot stack name variable, I'm giving stk. Stk means a stack. Stk equal to, initially, I'm not placing anything, none. I'll explain. Into size. With the specified size, one empty block will be created and that will be stored into this stk. That is the stack. And I already told you that we use one variable to perform all operations, that is called top. Top value -1 and size also. Size we place into self.size. That is called max size. This is just taking that initial input. Now observe. First step is, I'm just giving that message is stack is ready. Stack is ready. From outside, I'm not printing that directly. Directly, I'm creating S is equal to creating that stack object. Stack object we are creating by passing 5 as an input. Here also you can use STK. Inside confusing means what? You can use a stack directly. STK. Now look at this. When you run the, when you run the code, stack is ready. Sir, what you did explain. See, whenever you are calling this one object creation, constructor will call. 5 will go and store into this size. First here, we are creating like this. Is actually memory block with the sizes of 5 created like this. But actually, we should not represent like this. How we should represent? We represent like a stack. Physical representation like this. Size memory will be allocated. 5 locations like this. Value 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. That is. Stack is pointing to this block. So this is actually called stack. Next, top and size we mentioned. What is the top value? Is a -1. And what is the size value initially? That what you have sent 5. With this one, we created this one. We created this one. Because once that stack is ready, we are doing this one. Okay. Now, directly, I'm doing the push operations. Directly, I'm doing that push operation. Define. I'm using that function is a push. Self-compulsory for every method. So whatever the item you want to push, whatever the item you want to push, you can pass simply item or element, anything. It's your wish. Anything. But can you check directly? Directly push directly? No. If suppose if that top value self dot top value equals to size -1, directly we can say that stack is full. Stack is full. If stack is not full, what we have to do? Top we need to increase. Self dot top equal to self dot top +1 and into stack of self everywhere we have to use. Into that stack, which location? Into the top location. Already top increased now. Initially it is -1. But when you add +1, it is 0. Into that location, element added. That message I'm giving. Pushed. Element pushed onto the stack. That element also I want to print means what? Just element we are printing like this. Like this. Sir, by pushing that number of elements, I'm just checking. By pushing number of elements, I'm checking. Push 10. Push 20. Push 30. Push 40. Push 50. When you run this, look, push is not defined. Here it is. How to call that method? With the help. Push. Yes. With the help of that, we always call. just for checking, whether it is a full or not. Because size is a 5 elements pushed, okay. But next element, whenever we are trying to push, you will get that error. The stack is full. The stack is a full. So I'm not writing this one. Only just 4 elements I push. After that, I just want to display. We already discussed that code. How can we display? Technically, we can call it as a traverse. Traverse. Same story. Before going to display the data, we have to check that stack is empty or not. So if that stack is a stack value means what? If top value equals to -1, then we can say that it's an empty stack. Empty stack to display items. If stack is not empty, then we need to display. Stack items are simply for loop. We already discussed that. We need to start from the top. 0 means 0 minus 1 you have to give. Decreasing order. -1. -1 is a print. So what we are printing here, it is each element is nothing but stack self dot stack of I. Every time you need to specify like this. It is written. So simply we call stk dot traverse. stk dot traverse. See, all the stack items are printing whenever we display. Pop means what is deletion. There is a method called peek. Peek means it will display the top item, but it will not delete the top item. It will not delete the top item. That is also you need to implement, because in algorithm they have given it's a peek. Same. Here it is a empty stack to display peek item, or else it's very simple, easy one. That peek item is just we are printing top item. Top item means what? Self dot stack of top. Top means self dot top. Self dot top. We are just calling stack dot peek. Stack dot peek. Peek element is a 40. What is its meaning? Whenever you are going to delete the item, is always peek item will going to delete. Always that peek item we are going to delete simply. Okay. This is the same thing. Just only the thing is what is a pop. Pop is also doing the same thing. First, we are checking that empty stack to delete. We can't perform the delete option operation if they are going to pop the items. Else, the pop item is after printing this one, what I told, just top minus minus self dot top equals to self dot top minus 1. That's it. Deleted item. How many items I'm going to delete? Same stk dot pop. Again stk dot pop. Again stk dot pop. Again stk dot pop. 4 items deleted. Again, if you check stk dot pop, you will get that after 4 items deletion, it will give that output is a empty stack to delete. Empty stack to delete. So we are just implementing everything in this format, but here, just let me copy the things. But in this case, sir, here, everything I just want to read dynamically. I want to make it as a menu driven operations, menu driven. So the first step is we ask that size equals to integer of input, enter size of the stack, enter size of the stack. Then we create stk, we create that object and passing that size. Now everything is dynamic. Size of the stack. If I give 7, stack is ready. Then we can do all the stack operations. How can we perform? This is actually called menu driven implementation. While, sir, why we are using while instead of for loop? See, they have given 2 loops. One is a for loop. We always use when we know number of iterations, how many repetitions when we know. And when we use a while loop, when we don't know number of iterations. Here menu driven means what? How many times they will implement that stack operations that we don't know. So that's why fixed number of times means what? For loop. It's not fixed number of times means what? Is a while loop. So that's why here we are using while loop. We are using while loop. Here, first I am giving that print operations 1 to push element onto the stack. Is it 2? Just traverse the information. See, creating the stack, don't write inside because only one time we create that stack. But operations multiple times we will do. Traverse. Here it is a third one is a pop, is a fourth one is a peak. Suppose I am giving like this. And if you want to exit, come out of this one, just 5. So we ask, what is your choice? What is your choice? Among all, enter your choice. Input your choice. They can enter maybe 1 or 2 or 3 or 4 or 5 or other than 1, 2, 3, 4, 5. So we select that if choice is equals to 1. That is for push the element. So we ask enter element to push. Enter element to push. So that we are inserting, that you are sending to that stack. After pushing that, getting that element, by calling this push, we are sending simply stk dot push of element. That is, else if the choice is equals to 2, it's a second choice. Directly we can call traverse is for printing. Else if choice is equals to 3, this is deletion. Stk dot pop. Else if choice is equals to 4, if choice is equals to 4, then it is peak. Else if choice is equals to 5, then we can say that it is end of stack operations. End of stack operations, just break that loop. I don't want to continue. So sometimes if you enter by mistake other than 1, 2, 3, 4, 5, we can say that invalid input or invalid choice. This is simply called menu driven. So now when you run the code, I just enter size of the stack is only 4. So stack is ready. Now it is asking enter your choice. Directly if I give 4 peak, how can you? Empty stack to display the peak. We can't do. We can't do this. Hope you got it. Now I just want to push 1. If choice is 1, it is expecting to input 10. 10 pushed. Again choice is a 1. Is a 20 pushed. Again choice is a 1. Element 30 pushed. Again choice is a 1. 40 pushed. If you want to check to traverse, stack items are printing 40, 30, 20, 10. It's printing. Let us take, suppose if I'm going to display peak, that's a top item is a 40. Again choice is a 4. Again top item is a 40 only because you're not deleting. Peak means what? It is just displaying. It's not deleting. And now we are doing that. If choice is a 3, 40 removed. See now if I use choice, same choice 3. Now 30 removed. After 40, 30 removed. Now peak item is what? Is peak item. Choice is a 4. 20 because next item we are going to delete is a 20. 20 deleted. Again 10 deleted. All deleted. Now can you use once again? No, because it's an empty stack to delete. Sir, any wrong choice by mistake 7? Error invalid choice. Okay, I just want to exit from here. End of the stack operations. So in the previous case, directly we are giving. Directly we are giving. In 2 ways we are writing. So this is the way, simple way of implementing that stack with the complete theory.